Okay, so this is a video from Unit 2B, Lesson 3 notes about graphing quadratics in standard form. Just as a quick review, standard form is y is equal to ax squared plus bx plus c. That's our standard form of a quadratic. Okay, so the first step we always want to do is we need to find the vertex. Okay, so in order to find the vertex, I have to start by finding my x by using our formula negative b divided by 2a. So looking up here at our formula, I'm going to kind of use the highlighting tool here. I'm going to highlight my a, which is the number that's in front of x squared, which is just 1. I'm going to highlight b, which is negative 2. And I'm going to highlight c, which is negative 1. So plugging these values in, negative 2 for my b divided by 2 times my a of 1. I'm going to simplify. Negative makes this a positive 2. 2 times 1 is just 2. So 2 over 2 works out to just be 1. So my x value of my vertex is 1. But now I have to find my y. Well, my y is just whatever I'm going to take this x value in and substitute it in for all the x's. So 1 squared minus 2 times 1 minus 1. This gives us 1 minus 2 minus 1. Actually works out to be negative 2. So our vertex then is going to be found at 1, negative 2. So I go over here to my graph, 1 to the right, down 2. This is my vertex. So not only is my vertex here, but we also know our axis of symmetry is going to go straight through this. Okay, so I want to label this as our axis of symmetry. Okay, basically everything that happens on the right side is going to be reflected over to the right side. Now we're going to create our t-chart. Okay, we're going to always create 5 places to put in. So 1, 2, 3, 4, and then 5. In the middle, I'm always going to put that vertex because it's in our middle. And I'm going to choose 2 x values that are immediately smaller than 1, so 0 and negative 1, and 2 numbers that are immediately larger than 1, positive 2, and positive 3. I get to choose the x values, and the reason why I choose those is because they're going to give me values that are just right next to my vertex that kind of tell me which direction I'm going to be graphing it. So what we need to do now is we need to take each of these x values, and we are going to substitute them in back all the way up into our original equation. So it's going to be negative 1 squared minus 2 times negative 1 minus 1. Now a trick for these is using our calculator. Okay. And when we use our calculator here, okay, I kind of see some of the old work I have on here, but when we use our calculator, we're going to start with parentheses, negative 1, okay, parentheses, negative 1, negative's not working, negative 1, close your parentheses, squared, minus 2 parentheses, negative 1, close your parentheses, minus 1. Now notice that I put in parentheses every value I plugged in negative 1 I put in parentheses, and it tells me it's going to give me a value of 2. So now I know there's a point at negative 1, 2. This is an ordered pair. Negative 1, 2. And we can graph that on our graph. Negative 1, up 2. So I know there's a point here. Well, furthermore, now if I want to do 0, all I have to do is press second and enter, and the whole point comes back up. But now I can just go back in and change my negative 1 to be 0, because that's my next value I'm going to plug in. And it makes life a little easier, and I'm just going to get negative 1. So I now have 0, negative 1 as a point to graph. 0, negative 1. And I'm going to continue with this for 2 and 3. Second, enter. Scroll back to 2. Scroll over here. And replace the 0 with 2. And we get negative 1 again. So now I have an ordered pair of 2, negative 1. 2 to the right, negative 1. And then finally 3. When I get that, I get 2. So then I have 3, 2. 3 to the right, up 2. Now, what you're going to notice a lot of times when we do this is that the values to 2 for the y's, -1, -1, they're going to be the same a lot because this is the axis of symmetry we said. And axis of symmetry means that everything is going to be symmetrical. So anything on the right side should be the same on the left, and vice versa. Anything on the left should be the same on the right. So these distances that I'm away from the axis of symmetry should be the same. That's what gives us the opportunity to create this perfect parabola here because it's symmetrical through the axis of symmetry. So this is how we're going to graph all of our quadratics that are in standard form, which is to say ax squared plus bx plus c. We're going to continue to practice it. I hope this video helps.